byte is there. So in the case of that first one, 0, 0, 1, 0, 0, 0.
It'd come up to
0,
65
1.
there, I think. 65.
Then we're going to convert that number to decimal,
No, there's 35.
which should be
35.
128.
35, I was wrong.
33.
Yeah.
The 128's is a 0, 64's is a 0, 32's, we've got a 1 in there, so 1 and 32 and a 1 and a 1. That's going to give us the equivalent of 33. So that's what we would put right here when we put it in the machine. It looks like it's a host number of 33, but it's not. You've got to break it back into binary to look and see how much it breaks off. Second one happens to be then 0, 0, 1, 0, 0, 0, 1, 0. Guess what? That one's 34. Now follow how what's happening there? We're taking what we borrowed to keep onto the network. So we're expanding our network. We're borrowing from our host numbers. And then still using the rest of it for our host number. And then the two combined makes this. Now, our subnet mask for that one. And this is where subnet masks really come into play. We've said this portion of it we know is the network portion, right? First 3 bytes. So what's the subnet mask for the first 3 bytes? 255. 255. 255. Everybody follow on that? Now, the last byte, the subnet mask changes on. Because in that last byte, it's not all host number, is it? First 3 bits are network, right? So guess what? We got to use those first 3 bits. They got to be turned on in the subnet mask. So in binary, it's 11000000. Everybody follow on that? So what's our subnet mask going to be there in that one there?
240.
Because there it is in binary.
240.
The 128 plus the 264, it should give us 224. Because 128 plus 64 is 192, plus 32 gives us 224.
Off by 1 bit.
Does everybody follow where I got the 224 from now? And so the 224, this is what you would see in the subnet mask. Now remember the rule I just told you a few minutes ago. When we had them all up here, they were all 255s and zeros. Guess what? Now you see where there can be subnet masks. There's something other than 255s and zeros. However, that odd number that's not a 255 or a 0 can only occur in the byte that is between 255s and zeros. Anything to the left of it has to be 255s. And if there was numbers to the right of it, they can wander. They can't wander either. They have to be zeros. Okay? So that 1 byte there, there's only 1 byte allowed in there that can be something different than 255 and 0. If there's other bytes to the right of it, because let's say this is a class A address. So 255, and we had borrowed the first 3 bits out of our host numbers. So 224, and then the rest of them will be 0. So to the left, it's always going to start with 255. You can't borrow out of that first one, so you always start off with 255 with a subnet mask. Does not always end in a 0 because in a class C, it is ending in binary zeros, but it does not necessarily end in a decimal 0. But if you've got a number other than 255 and 0 somewhere in there, it's got to come between the 255s and the zeros. And nobody ever told me that one before I even really thought about that today. Or if they did, it went over my head. So don't ever look to see, if you ever see a number that sits there and says 255.224.255.0, is that a valid subnet mask?
Nope.
No. Is that a valid subnet mask? Yes. There's 255, 255, and 252 actually is a valid one. Because that says we're borrowing the first 6 bits. The last 2 bits, 1 and the 2, we're not using. And 3 plus 252 gives us 255, so that'll work. Okay? But notice the number came between the 255s and the zeros. Binary-wise, it's all zeros through the 3rd spot here. And then the 5 spots are all 1s, followed by all 1s, followed by all 1s. My suggestion to you is, when you're looking at the subnet masks, convert them back into binary to look at them. And if you ever get given a list and they're saying which are valid and which aren't valid subnet masks, you might want to convert to binary when you get down to, because you can probably eliminate 1 or 2 of them, just like we had up there on board a moment ago, that didn't follow our rule, 255s to the left, zeros to the right. Okay? But something got mixed up in the midst of it. So you can probably eliminate a couple of their answers, but if they've written the question well, you've got 2 answers sitting there still going, all right, now one of them's right, one of them's wrong. Put them in binary and see what you got. If it's not all 1s followed by all zeros, it's not a valid subnet mask. But the whole object of the subnet mask is to be able to look at that it is compared to the network address. And they can present you a whole complex way of determining that, of ANDing and ORing is what they'll tell you. Where you can go through, and those of you that have taken some more advanced math somewhere along the way, you learned ANDs and ORs, to go through and figure out what it is. But it really comes down to a simple little condition. Convert your number of your subnet mask to binary. Convert your IP address to binary. Or if it happens to be one that's all 255s and 0, you don't even have to convert it to 0. You can just, to binary, you can just simply convert it. Look at it and see. But convert it to binary, and then everything that lines up in the IP address, that lines up with a 1 in the subnet mask, that's the network address portion. Everything in that IP address up here that has a 0 in the subnet mask is the host number. Questions on that? That's putting it real, trying not to get too deep. It's real easy when you get real deep in this. Okay? Major thing is to be aware of. You can borrow out of the host portion to make subnets within a network. You can break your network into smaller networks. You've got a big network address, and then you're taking parts of the next part to make your subnets. Okay? And so you're borrowing from your host to make those subnets. But as far as network portion and host portion, that shouldn't be real difficult to you. We do it with names. My name's Dwight Watt. What do we know about that? We know the first name's Dwight, last name's Watt. Actually, my first name's not Dwight. It's the middle, but that's beside the point. But the last name's Watt. So since we know we're in a Western culture, we know the Watt tells us that's the family I'm a member of, right? And that everybody in my family probably has the last name of Watt. And that anybody else that's in the group around me that's got a last name of Watt is probably kin of mine, right? And that the first name is the individual of me. Similar to on here, the Watt would be the network portion, the Dwight's the host portion. Dwight is which person in that Watt house at home. As you walk into somebody's house and you just yell out their last name, that doesn't get you one person, does it? That should get you everybody. Now, I do know a family or two that doesn't exactly follow on the whole thing. But that's how it normally works, right? You call out the first name, you're assuming they all got the same last name since you're in the house with them right there. Okay? And so you call them by the first name. Of course, we all realize that growing up, that if you get called by the whole name and it's by your mom, that you're in deep trouble at that point. Does everybody follow the difference in the network portion and the host portion? And what the subnet mask does here? Now, what's been covered in lesson 2, and what they're covering in the introduction to networking part, about subnetting and IP addresses, is very simplified. It's TCP/IP. You can go a whole lot deeper. There's entire books and entire courses taught on TCP/IP. And you can go way deep on this whole stuff. Microsoft on NT4, MCSE, one of the exams, that was an optional exam on it, was an exam just on TCP/IP. You can still find the entire textbooks out there. And actually, there's a new one, and that I've given, I don't know if I sent it to y'all or sent it last quarter. I need to send it to y'all also, if I did. That Microsoft has an online book sitting out there covering TCP/IP. There are several chapters on it that you can go out there and look at. You can see how deep it can go. You can do all kinds of things off address. But TCP/IP can do a lot of stuff to it. And that's one of the exams I did pass to get in my MCSE and MCP plus I in NT4. Because when I hit TCP/IP, I said, I can follow a pattern and see what's happening here. Now, for some of you, you're going, this is way more than what I probably want to know, but you've got to know the basics of it to set up a network. Okay? To understand what those addresses are on those machines. Any questions? All right.